Hi everyone, my name is Bodo Abakar Muhammad. I am an AWS Certified Solution Architect Associate. So in this demo, I'll walk you through a production style AWS 3-tier architecture project I built using Terraform and GitHub Action. So this project focuses on real-world cloud engineering practices, including modular infrastructure as code, remote Terraform state management, secure networking, HTTPS routing, and auto scaling, monitoring, application deployment automation, and production style dev and prod environment. And this architecture is deployed entirely on AWS. As you can see, user can access to the application from the internet through Amazon Route 53, which hosted my custom domain. And then from Amazon Route 53, traffic will be routed toward the application load balancer. So here there are two things attached to the load balancer: AWS ACM, which will uh, terminate HTTPS. It ensures traffic is encrypted, and the web application firewall, basically it's going to filter all the traffic, to check whether there are some SQL injection or any link that is suspicious before traffic reaching the load balancer. So once traffic arrives to the load balancer, and this load balancer use host-based routing, which means traffic will be routed to multiple target group, as you can see in this diagram. This is TG1 target group for app 1, and this is TG2 target group for app 2. For example, if the user here enter from the internet app1 body.org, so the load balancer will automatically route to this target group. If it enter app2 body.org, the load balancer will route the traffic to this target group. That's why it use a host-based routing. So as you can see, behind the application load balancer, the application run inside another scaling group, uh, and the EC2 instance uh, are deployed in a private subnet, for security. And this is not publicly accessible. For example, if for administrative access, if you wanna to access the private instance, I implemented AWS System Manager Session Manager instead of bashing host, to access securely. For I can, have a public EC2 or bashing host inside the the public tier, and I can SSH to the private instance using a public IP and private key, but it's not secure. That's why I implemented a session manager, which does not require a public IP or private key. It's production. This exactly what production how they can access to the private instance. So one of the most important part of this project is the Terraform modular architecture. So let me show you the architecture. So instead of putting everything into a single file, a single Terraform file, I separated, the infrastructure into reusable module. As you can see in this, uh, I created the model. You see, this is ACM uh, for certificate manager. This is the has all the files, and this is the ALB model, you know, and then this is the app model. It has the user data, variable, and main. And this is the IAM model. It has the main, variable output, and then this is the monitoring model, and this is the RDS model. It has all the, everything, all the RDS component. This is the Route 53 DNS model. This is the security group model. It has all the security group, as you can see, ALB security group, the app security group, this is the DB security group. So it has all the security group. It's very secure way. So, and this is the VPC model. It has all the VPC component, as you can see. And this is the web application firewall model. So basically that's is gonna be very easy, to make change, to, or for example, if I want to make change in a specific place inside the VPC model, I can make change without, touching the other parts. So, and it also make the code clean and readable, and you can reuse, model in a multiple places, if I want, and it's also help to for it helped the team, to collaborate, successfully. When you use the model, it make, the other teammate can read your code, without having, difficulties. So also I implemented, the dev environment. I separated the dev environment, and then production environment. So I put the environment inside the environment file, the dev for development, right? So this is for production. So this is also production grade style. So on the top of that, I implemented the remote Terraform state management using Amazon S3 and DynamoDB. So the Terraform state file is stored centrally in an S3 bucket, while DynamoDB is used for state locking. Basically, this prevent multiple engineers, from modifying the infrastructure simultaneously, and it protects against state corruption. This is very important, production grade Terraform best practice. So whenever, for example, something happened, you run Terraform, somebody run Terraform, it destroy the entire infrastructure. So you have, this is remotely, you can recover the entire infrastructure, from the TF state file. So that's why it's safe and in best practice to keep it, remote from the remaining infrastructure. Okay, for example, for infrastructure deployment, I create a separate, GitHub action workflow for dev and prod. So let's see, this is the dev YAML file, and this is the prod YAML file. Basically, if I run the dev YAML file, the dev YAML file run automatically when, the Terraform code change, while as, production pipeline is manual, and it require approval, you know through GitHub environment before deployment. Basically, those workflow, what they do is that, what they perform is that they perform the Terraform formatting checks, and Terraform validate, plan, and apply. So on the top of that, for authentication, I use AWS OpenID Connect. GitHub Action can authenticate, can authenticate securely, as you can see, can authenticate securely uh, to AWS using this credential. So this basically remove the need for having for long-term AWS access keys, inside GitHub, and follow a more secure authentication model. So I also created a separate CI/CD pipeline for the application deployment. So, for example, when the application code change, basically the pipeline, action will run automatically. So let me show you the pipeline diagram. So basically, for example, whenever the developer make a change and push the code inside the GitHub repository, this will trigger, the GitHub action. Everything here will run automatically. It's going to build an zip app1 folder and zip app2 and upload those zip files inside the S3 artifact packet. So after the file uploaded, those files are going to be downloaded from the they are going to be downloaded from the uh, or scaling group, right? They are going to be downloaded from the user data inside this server, and then this and then it will trigger auto scaling group instance refresh. So it will refresh to use the latest uh, version, and when you check the application in the browser, you will see the change will be reflected. So without further ado, I'm going to demonstrate all the those all those I discussed. So basically I'm going to test the development and then the production. So let's navigate to the let's list the directory first. So let's navigate to environment, cd. Let's go to dev, and then here we can run Terraform init. So I need to run the Terraform init with the configuration, for the dev environment, because I have two, environment. So whenever I want to run dev, so I have to use the backend dev, which is this one. So when I want to run production, I have to use production backend. So it's successfully initialized. So I'm gonna be running Terraform validate. So the configuration is valid. So now I'm gonna run Terraform apply order approve. So the Terraform apply also success. Now let's test it. So as you can see now, the browser, the app1 which is basically the app1 has my resume. The app1 file has my resume, sample of my resume, and let's test the app2 as well. So basically when I put app2, the load balancer is going to redirect to the app2. So this is app2. So it's custom domain, you see it's secure, HTTPS connection, everything is working as expected. So now what we're gonna do is I'm gonna test the pipeline. I will make a change and then run git push. We'll see the change. So let's see, this is the app1, which is my resume. I'm gonna be removing my last name inside the index.html file, and then run the GitHub command, and the Git workflow basically will run automatically. This is going to be removed. So this is the power of a pipeline. So let's go to the index.html. Let's put the app1 index.html. So this is the file. So I already remove it now. So and then now once I run the git command, so let's navigate to the main directory cd. So here we can run the git command to push it to the GitHub repository. So now let's run git. I will add to all the file git commit change name on one. Okay, now git push. Okay, so now let's see how the pipeline is going to work. Basically, it's going to run automatically. Let's refresh it. As you can see, it's running automatically without any manual intervention. So let's just see. It's gonna finish. Still running. Now it's successfully run. Let's click and see. So now basically what it does is that it built in just 37 seconds. It does all this job, you know. It built, you know, and zip the file app1 and app2 and upload those files into the artifact S3 artifact packet, and then from the S3 artifact the instance, you know, refresh it's generated. Basically it took only 37 seconds to, you know, run the pipeline. So this is a powerful and it's very good. So now let's see the change on the browser. Let's just refresh it. You see, just automatically it disappear. So we just demonstrated how this pipeline, this is a full pipeline. So now I'm gonna test, this is the application pipeline, but now I'm gonna test the dev pipeline. So now let's see first of all, let's just see on the console. So let's go to EC2. I will make a change on the infrastructure, and we're gonna see how this pipeline will work. Basically, this is the auto scaling group. Let's just see. I will make the tag. So I'm gonna change. This is I will make a run test on this pipeline. I will make maybe full pipeline dev test version 2 or something like this. I'm gonna add something on this on the infrastructure, and we're gonna test it, and then we will see the result. So now let's go to the dev environment. Right, so this is the production. Let's go to the dev. Inside the main file, okay, let's see, I think it should be somewhere right. So now I will add maybe version 2, yes, okay, same for copy. This is for app 1, same for app 2. Let's make it version 2, and then now let's see. So now as I made the change, let me just push it to, let me add first, so I can use this git add, that's gonna add all. But if I want to use the specific file that I made the change, for example, I made the change on the main file, main inside environment file, and then I made inside dev file, dev folder, and dev inside environment. So now what I'm gonna do is I'm gonna write environment. Wow, what is this? Environment, environment, and misspelled, and right, and then dev, then main.tf, right? So that's how I can add it specifically. Now git commit -m, so update on dev, update on dev infrastructure. So, right, so let's git push. So now the pipeline will run automatically. Let's see. Okay, let's just refresh and go out. As you can see, this pipeline, the pipeline is running automatically without me touching it. So let's just wait for a few seconds and see. Still running. So as you can see, it's successfully, the pipeline successfully run. And let's see, it took only 43 seconds, you know, for the pipeline to run. So basically all this job is done in 43 seconds. So check the formatting, Terraform init, you know, validate, and also apply, use the AWS config, you know, to authenticate, is done in 43 seconds. This is the powerful of pipeline. So now we're gonna see the change that we made on the, let's refresh. As you can see, inside the all group, we just added the this is the tag, we just added the version 2, so it's automatically reflected. So let's check for the app 1, this is app 2. Let's see, the tag is also added, it's automatically. So we successfully run the pipeline and tested it. So now I'm gonna be running the production pipeline. I can, you know, demonstrate how the production it's basically it's gonna run manually, and it require approval. It's production, that's why it's more secure. This is the development pipeline is gonna run automatically. For production, that's gonna require approval and it's manual. So let's just test it. So now it's time to test the production. So let's go out. So let's cd port. So now we are in production directory. I'm in production directory. So I run Terraform init. So as I'm running Terraform init, I have production. I have to configure with the backend. You see, this is the production backend, which is this one. So that will successfully initialize it with the production configuration. So it's successfully initialized. So I'm gonna run Terraform validate and apply. So the configuration is valid. Let's run Terraform apply or apply. So now the production environment successfully completed. So this production is now gonna run automatically like the dev environment. So basically we're gonna run it manually, but it's gonna require approval. So let's go out. Let's go to prod. As you can see, let's trigger run workflow. We need to run it manually. So it's gonna require us, as you can see, this username, this is my username, requested to review, to deploy to production. So now this is the approval. I'm gonna review, right? So once you are happy, just click here, and I can leave some comment if I want. I can reject if I want, but I can approve and deploy. Still running. As you can see, it took 1 minute and 12 seconds to run the production because it has more job than the dev environment. So the other one, it took only 43 seconds. So now let's run the application for the prod. So this one also is going to require approval. Okay, so let's review. You can leave some comments. Let's deploy. This time it has 2 jobs. That's why it is going to require me another approval for the second job. So I have to again review, deployment, check, and approve and deploy. See, this is how exactly they do in production. So now it took only 55 seconds to be completed. So now it's success. So now as you can see, this validate the full CI/CD pipeline. The demonstration is successful. Now we finish with the CI/CD pipeline, and one of the most important part is the monitoring security. So let's see. So as you can see in this small diagram, I also implemented a monitoring and operational visibility. This is a CloudWatch dashboard, with alarm monitor. Basically, this dashboard, it will, you know, load, it will, what it does is like, is going to record the load balancer metric, the target group health, order scaling activity, and the web application firewall block request, and then the EC2 performance. As you can see, all this is going toward the dashboard. So this is for the web application firewall, and this is the EC2 order scaling group metric. So they all go into the dashboard, and this is the now this is for the EC2 instance. So now let's go to the console, AWS console, to see it visually. Let's go to CloudWatch. Yeah, it's now kick me. So as you can see, we are inside the CloudWatch. So let's go to the dashboard. Okay, this is the three-tier app production dashboard. So we can open it and see all the dashboards are here. So from here we can monitor, all the activity, ALB request quant, healthy host. This is especially for the target group. It's gonna show whether it's healthy or not healthy. Count is 2 because we have two, app 1 and app 2. This is the web application firewall allow versus block request. It's going to show us, for example, all the block requests and allow requests. This is the ALB X55 error, and this is target group response time. Basically, this is the dashboard. You can successfully monitor the activity, and also, for example, if it's something is gonna, I also set a SNS topic. For example, if the web application firewall, metric is too high on the dashboard, that's gonna trigger alarm, which will send an SNS topic, and then it will notify me to my email, as I said in my email. So when I run Terraform apply, it asks me for configuration. So yes, and one more important thing, I'm going to demonstrate how I can access to the private instance from. Yes, I'm going to demonstrate how I can access, the private instance using Session Manager, you know, that I implemented. So let's go to the console. Let's go out, and then let's go to System Manager. From System Manager, we need to Session Manager. Okay, let's start a session. Okay, I'm gonna select. Okay, let me select the app 1. The one I select app 1 production. I start the session. Start. So I logged in inside the application. So now I'm going to test whether it's gonna, I am inside app one, the app one which hosts my resume. So let's see, let's run the curl command. Curl uh, curl localhost host. Yeah, basically that's showing successfully. You see, this is the index.html for my resume file. So I successfully demonstrated the last part. I access, you know, to the private instance from Session Manager without, requiring public IP or private key. So during this project, I solved several real-world engineering challenges, including Terraform backend state checksum mismatch, and IAM uh, open ID OIDC trust relationship errors, auto scaling instance refresh conflict as well, and also I encounter ALB target group, health check filer, and also ACM DNS validation issues, S3 bucket cleanup during infrastructure destroy, GitHub, action YAML troubleshooting. So basically, all those challenges, help me to build stronger operational and troubleshooting skill in AWS and Terraform. Again, this project helped me, gain hands-on experience on AWS architecture, infrastructure as code, CI/CD, automation, monitoring, security, and cloud operation. So thank you so much for watching.